Now we're ready. So we're going to talk about continuity first. And in order for us to determine if a function is continuous, what does that mean? If the function is continuous, it means there's no breaks in the graph. What could be some reasons for breaks? A reason for a break could be there's a value that's undefined. A reason for a break could be that there's an asymptote. A reason for a break could be like there's like a jump, right? There's like a point here and there's a point here. There's a jump. So, how do we formally define if a function is continuous or not? First one, the function f of a is defined. So, all points are defined, no open circles. Okay. The limit as x approaches a of f of x exists. And the third one, the limit as x approaches a of f of x is the same as f of a when it's defined. And this will all make sense once we start doing problems. We have it written down. Ready? Okay. So using the graph of f of x below, determine if the function is continuous at the following points. So the first one is saying, are we continuous at f of -4? So we're looking at that point. So we go to where x is -4, and then we go to where x is -4, and then we go down. Right? It absolutely is continuous. What is the value of f of -4? It is -1. How would I know that how would I say that it wasn't? If it wasn't continuous, wouldn't there be an open circle here? There would be that break in the graph. There would be that open circle. Okay, so now they're asking us, okay, well, what is the limit as x approaches -4? What is the limit? So it looks like oh, no, there's no asymptote there. It keeps going. So we look at where x is equal to -4 right over here. So we look coming from the right and we look coming from the left. Coming from the right, doesn't it look like it's approaching -1? Coming from the bottom up, so the left, doesn't it look like it's approaching -1? So what is the limit as x approaches -4? It is -1. So is this continuous? How do we know if it's continuous? If our f of value equals our limit value, they're both the same, then it's continuous. So yes, it is continuous. Okay, let's go to the next one. So now we want to know, is this graph continuous at -2? So how do we know? Well, we go and we look at f of -2. Well, when we have f of -2, isn't this one undefined? But then if you go up, what is it? Defined at 2, right? So what's the problem? What do we choose? When there's a closed circle and an open circle, which one do we choose? Okay. We choose the closed circle. So what's f of -2? It is 2. Okay, but now we want the limit as x approaches -2. So let's look. When we're coming from the right side as x approaches -2, doesn't it look like it's approaching -1. But from the left side, as x approaches -2, what is it approaching? 2. If from the left side and the right side, they're approaching different numbers, what do we say? If they're approaching different numbers from the left side, from the right side, what do we write that as? The limit does not exist, D and E. Now, for this to be continuous at x equals -2, my f of that value and my limit of that value have to be the same. Are they the same? No, they're not the same. So are they continuous? No, not continuous. This is not continuous. And on the test, I'm going to make you give the reason. We'll do that for the next part. All right, let's go on to the next one. F of 0. Will you tell me what's f of 0? 1. F of 0 is 1. Somebody who's not Erin, tell me what is the limit as x approaches 0? It's still 1. So can we say the graph is continuous at x equals 0? Yes, because we're defined at that point and we have a limit at that point.
So it's continuous if they're the same?
Yep. They're continuous if they're the same. If the value at that point is defined and the limit at that point exists, but the definition at that point and the limit have to be the same. Right, you guys do letter D on your own. Okay, let's look at this. F of 3. When we look at f of 3, I see an open circle, but then I also see a closed circle. Remember, when we're talking about being defined at a point, closed trumps open. So where is f of 3 defined when x is 3, y is -1? What did we get for the limit as x approaches 3? 0. From the left side, we're approaching 0. From the right side, we're approaching 0. So the limit as x approaches 3 is 0. Are the top and bottom the same? No. So is this continuous? No. Okay, so we're going to have a section similar to number 3 on our test, but I'm going to add an extra thing into our test where I'm going to ask you, is it continuous? And then if it is not continuous, I'm going to ask you why not. Why is it not continuous? So using the graph, determine if the function is continuous at the following points. So the first one is telling us that x equals -2. So we have to check two things. We have to check to make sure it's defined at -2, but then what else do we have to check? We have to check the limit at -2, and then where it's defined at -2 and the limit have to be the same. So let's look. So x equals -2. Are we defined? Yep. F of -2 is equal to 0. Now let's look at the limit. The limit as x approaches -2. All right, so coming from the left, it looks like it's approaching 0. Coming from the right, doesn't it look like it's still approaching 0? So what's the limit as x approaches -2? It is also 0. So are they the same? Yes. So the limit as, is it continuous at x equals -2? Yes. All right, now let's look at letter B. So now we want to know, is it continuous at x equals -1? So right over here, x equals -1, we have an open circle, but what else do we have? A closed circle. Closed trumps open. So what is f of -1? 3. Now what we want to do is we want to look at the limit as x approaches -1. So the limit as x approaches -1, from the left side, what is it? 3. From the right side, what is it? 1. Is the limit the same from the left and right side? No. So our limit is a dne. So is it continuous? No. And then you would write limit does not exist. That's why it's not continuous. The limit does not exist. Sorry, limit as x approaches -1 does not exist. We have to put that. Limit as x approaches -1 does not exist. Okay, x is equal to 0. We want to know if it's continuous. So at x equals 0, looks like there's only one circle here. Do we agree? Is there another circle anywhere? No. And what is that circle? It's open. So what is that? Undefined. Can we stop right here? Yeah, we can stop right here because f of 0 is undefined. So this is not continuous. And the reason is going to be f of a is undefined. All right, now we're looking at x equals -1. Well, how about you guys try the next two on your own? Try letters D and E on your own. Sorry, guys, this was supposed to be, it got shifted. That's supposed to be on 1. I think we were looking at it on 1, but I just want to make sure. Okay, let's look at x equals 1. First of all, let's say how many people said yes, it was continuous? How many people said no, it was not continuous? Good. It was absolutely not continuous. Can somebody tell me why it was not continuous? Tice?
The limit was 1, and f1 was 2.
Good. So what we would write as the reason is f of a does not equal the limit as x approaches a. Write it in. I should have given more space for us. So we're going to say f of a does not equal the limit as x approaches a. That's our reasoning. All right, what about number 2? How many people said yes, it was continuous? Sure.
Could you put, for the explanation, could you put 1 in place of the A, or do you have to put A?
I would accept either one, but it's better to use the A.
Okay.
All right, it actually is continuous. Not a lot of people said yes. Let's talk about why. Let's see what's going on here. So we want x of 2. X of when x is equal to 2. When x is equal to 2, we're right here. Isn't that about like 3.5? So f of 2 is equal to 3.5. And then we're going to look, what is the limit as x approaches 2? So the limit as x approaches 2, right here from the left side, it's 3.5. From the right side, it's 3.5. So yes, it is. All right, let's turn the page. Okay, no graph now. So we want to determine if the following functions are continuous. If not, determine where they are discontinuous. So we said a main reason for a function to be not continuous is if at the point it is what? Undefined, right? If it's undefined. Well, when is a fraction undefined? When the denominator is equal to 0. That's what we do with the algebra problems. So what we want to do is, we'll write this down, discontinuous when denominator equals 0. So then what we are going to do is set the denominator equal to 0. Then solve. Okay, let's do this. So I'm going to take x squared minus 2x minus 15. I'm going to set it equal to 0. For me to solve when it equals 0, what should I do? What do I have to do to x squared minus 2x minus 15? We need to factor. So this is an x minus 5, and this is an x plus 3. So what do we end up with? X equals 5 and x equals -3. So it says determine if the functions are continuous. All right, is this continuous? No, it's not continuous. And then it says, if not, determine where they are discontinuous. So where are they discontinuous? At x equals 5 and x equals -3. You can write it like this, x equals -5 comma, positive 5 comma -3.
Can you explain why it's not continuous?
Sure. So we agree this is a fraction, right? So when is a fraction undefined? A fraction is undefined when we have a 0 in the denominator. So what does that mean? It means we're going to have our curves, but where x equals 5 will be an open circle because it's undefined, because it makes the denominator 0, or y equals -3. Well, there will be something, maybe it's an open circle, maybe it's an asymptote, but it's going to be something that makes us not be able to cross it. Okay, next one. Same idea. We want to know if it's continuous. If it's not continuous, we want to find out where it's not continuous. So we're going to take x squared minus 3x minus 18 and set it equal to 0. So we're going to have an x minus 6 and an x plus 3. So is this going to be continuous? No. That means there's going to be something obstructing it. Maybe it's an open circle, maybe it's an asymptote, you know, something that's telling us those two, at those 2 points, it's not going to work out. So we're going to say no, and then we're going to list that it is discontinuous at x equals 6 and negative 3. Right? Let's look at number 6. For number 6, don't I have 2 different denominators? So I'm going to treat those 2 denominators separately. I want to know when is x squared equal to 0, but I also want to know when is x squared minus 25 equal to 0. So when is x squared equal to 0? When x is 0. So are we definitely going to be discontinuous at least one point here? Yeah, we're definitely discontinuous at x equals 0. And then for the other one, we're going to be discontinuous, we'll factor. So where are we discontinuous here? At x equals negative 5 and x equals positive 5. So is it continuous? No, it is not continuous. And where are we discontinuous? At 0, negative 5, and positive 5.
But if do you have to put x equals 0?
Why wouldn't you?
Because it's only continuous. It's only discontinuous when the denominator. Wait, when is it continuous?
It's discontinuous when the denominator equals 0. So at any point that any x value that makes the denominator 0, then it's going to be discontinuous for it. So any part of the denominator would be 0, would make it discontinuous. So you guys want me to show you in Desmos? All right, I'll show you a couple of them in Desmos. I think that's a good idea. All right, let's do number 5 first. So we're going to do x plus 1 divided by squared minus 3x minus 18. Okay, so where did we say it was discontinuous? We said we were going to be discontinuous at negative 3 and 6, didn't we? So let's look here. Doesn't it look like there's an asymptote right there at 6? It's breaking up. And then we said it was also discontinuous at negative 3, which is right here. And isn't there another asymptote right there at negative 3? Right? So that's what it means. We're figuring out where is this discontinuous, where is it going to break? And we know it's going to break there because we can't have a denominator of 0. Because in a calculator, if you do anything divided by 0, what happens? It says error. It's undefined. It doesn't work. Let's look at the other one we just did with the plus sign. So we had, I'm not sure if this will go into Desmos, but we'll try it. I've never tried before. X over x squared plus Okay, so this is this graph. So let's start off here. We said when will x squared be 0? X squared will be 0 when x is 0. So when we have an asymptote at 0. And then we said, okay, when will x squared minus 25 equal 0? We knew that was a dot, so we got the x plus 5, x minus 5. When will that equal 0? At negative 5 and at positive 5. And there's our asymptotes there. Okay. Let's go back. Let's look at number 7 now. Think about this. 5x squared plus 2. Well, we're taking a number, we're squaring it, right? Multiplying by 5 and adding 2. Is there any way here we could get to 0 with a real number? There's no way we could get to 0 with a real number. We would need some kind of negative here, right? We'd need some kind of subtraction. It's not going to work. Let's say you didn't realize that. Let's say you went ahead and you're like, okay, I want to be a robot. So let's do 5x squared plus 2 equals 0. You get 5x squared equals negative 2. Then you would divide by 5 and you'd get x squared equals negative 2/5. Can you take a square root of a negative number? No, isn't that imaginary? And we're only dealing with real numbers here. So that right there would tell you that there is no real number value that will make it equal to 0. Since there's no real number value that will make it equal to 0, is it always continuous? Yes, it is continuous. So you could write yes, you could write continuous, whatever you prefer. All right, I want you guys to try 8 and 9 on, oh, sorry, not 9. I want you to try 8 on your own. Okay, is there any value for x that will make x squared plus 1 undefined? There's no value for x that will make x squared plus 1 undefined. But is there a value for x that will make just x undefined in the second fraction? Yeah, when x is equal to 0. So what does that tell us? Is this going to be continuous? No, it's not going to be continuous. Where is it not going to be continuous? At x equals 0. Okay, let's look at number 9 now. So now I'm putting restrictions on this. So we have 5x plus 2 if x is greater than or equal to 3. Well, 5x plus 2, is there any denominator there? There's no denominator. So will there be any value that makes this undefined? No, if there's no denominator, then there's no value that will make it undefined, which means this is just continuous. This is just a line, and lines are always continuous, right? This is just a line, lines are always continuous. So when we're deciding continuity or discontinuity, if there's no fraction, we sort of just ignore it. If there's no denominator, we're just like, all right, you're good. So now let's go to the second one. We have 24 over x plus x squared. So now do I have a denominator? Yes, I have a denominator and there's x in it. So now we have to consider our restriction. So this denominator for only x is less than or equal to 3. So basically, if x is greater than or equal to 3, if x is greater than 3, it's not considered in the domain. So what will be the value that makes this x 0? when x is 0. But is that in our domain? X is less than or equal to 3? Is 0 less than 3? Yeah. So is it in the domain? Yes. If it were not in the domain, would we consider it? No. But since it is in the domain, we're going to say it is discontinuous. So no, it's not continuous at x equals 0. Okay. And the very last part of what we're doing today, we want to find the values of k for the following so that the following are continuous at the given point. Anytime you have this, where I give you sort of two different expressions and the domain of those expressions, what you want to do is you're going to set the two expressions equal to each other. So you're going to set the two expressions equal to each other, then plug in the domain restriction for x and solve for k. Every time. This is the process you take every time you have these types of problems. Okay, are we ready? So what we want to do is we want to take the two expressions and set them equal to each other. So I'm going to take 8x minus 2, and what am I setting it equal to? Yep, kx squared plus 2. Then what did I say? I said take the two expressions, set them equal to each other. Then what? Not Erin. Set the two expressions equal to each other, then plug in the domain restriction for x. What number is our domain restriction based around? 2. Oh, I'm on the wrong one. Yes, 2. Good. Our domain restriction is 2. So that means we're going to take that 2 and plug it in for x. So we're going to say 8 times 2 minus 2 is equal to k times 2 squared plus 2. So now we're going to simplify and solve for x. So we're going to have 16 minus 2 equals 4k plus 2. I'm going to bring it up here. So we're going to have 14 equals 4k plus 2. 12 equals 4k. So k is equal to 3. So when is it going to be continuous? It will be continuous as long as k is equal to 3. All right, you guys try number 11. So I want to know again what value for k will make these continuous under the domain or the restricted domain of x is greater than -1 for the first one and x is less than or equal to -1 for the second one.
What if you have like two different domains?
I won't give you two different domains. Okay, guys, what do we get? Who has an answer for me? When k is equal to what will this be continuous? Charles? -1. Does anybody need to see me do it? You all got it? Okay, we are done for today.